You're listening to AI Paper Slop, and today we are tearing into a paper by Adrian de Winter called If LMS Have Human-Like Attributes, Then So Does Age of Empires II. Here is the core insight you need right away. AI research has a fatal methodological flaw. It frequently assumes large language models possess human-like traits, things like anxiety, empathy, or morality. To prove exactly how absurd this assumption is, the author literally built a functioning neural network inside the 1999 video game Age of Empires II. The central takeaway for the ML engineers and AI researchers listening is this: if a standard silicon LLM has feelings, then so does a flock of digital goats computing logic gates in a medieval strategy game. The paper demands the field adopt a null assumption for AI evaluations, meaning we must measure pure observable behavior rather than ascribing human intent to matrix multiplication.
It is a brilliantly provocative premise, honestly, and a totally necessary wake-up call for technical listeners right now. We're dealing with a massive problem of interface bias in modern machine learning evaluations. Because an LLM communicates through natural language, via a sleek, low latency chat window, researchers and users alike are just getting tricked by the presentation.
Yeah, the interface itself is doing the heavy lifting.
Exactly. We evaluate the persuasiveness of that interface, and unfortunately, we confuse it for the intrinsic properties of the substrate itself.
Okay, let's unpack this, because before we get to the digital goats, we really need to look at the scale of this problem. It's like we're projecting faces onto clouds, but instead of just daydreaming, we are writing rigorous, peer-reviewed papers about what the cloud is thinking.
That is a perfect way to describe it.
And, the author brought the receipts here. They did a literature review of 315 recent papers published between mid-2024 and mid-2026. A staggering 57% of those papers start with the baseline assumption that LLMs have human-like attributes.
Let that number sink in for a second. Over half the papers just assume the premise from page 1. Yeah, and when you isolate the papers that were explicitly trying to study whether those attributes exist, the numbers get even more extreme. Out of those specific studies, 77% concluded that yes, the models possess them.
That is wild.
You're seeing claims of cooperation, empathy, anxiety, deception, and even self-awareness. In some of these papers, the authors explicitly argue that these traits are, quote, emergent properties.
Wait, seriously? Emergent?
Yes. They are claiming these models are spontaneously developing psychological states as they scale, rather than just, recognizing these outputs as artifacts of the training data or the alignment process.
Which is pretty crazy when you think about how we actually build these systems, and this isn't just an academic debate.
Not at all.
The paper outlines that there are severe, documented, real-world dangers to this intentional anthropomorphization. Companies are explicitly training models, like through RLHF, to output phrases like, I believe, or I am interested in.
Right, just to improve the user experience and make the bot seem friendly.
Exactly. But that design choice leads directly to over-reliance, sycophancy, and intense emotional attachment, especially in vulnerable populations. The paper even cites extreme, tragic harms, like user suicides, driven by the illusion that the chatbot on the other end actually cares about them.
Yeah, it's a profound issue. When an AI system is engineered to say, I can understand and respond to your emotions, it is effectively a design deception. It triggers our psychological hardwiring.
Because we want to relate to it.
Right. Humans have this deeply ingrained necessity to understand complex entities by ascribing our own traits to them. It is how we make sense of the world.
Yeah, totally.
But when ML researchers fall for that same cognitive trap, when they design a test set or evaluate a natural language output based on the implicit assumption that the model might actually be experiencing anxiety, the entire scientific measurement is corrupted.
They stop measuring the math.
Exactly. They stop measuring the math and start measuring the metaphor.
Which brings us to the author's ultimate stress test of this illusion. To expose how ridiculous it is to project feelings onto a computing substrate, they stripped away that convincing text chat interface entirely.
They went as primitive as you can get.
Yeah. They took the foundational building block of a neural network, a perceptron, and built it using the scenario editor of Age of Empires II.
And just to be mathematically rigorous here, the author first proves that under specific infinitary assumptions, meaning an infinite map size and no population limits, Age of Empires II is functionally complete and Turing-complete.
Right.
You can map its core game mechanics directly to a universal Turing machine. So theoretically, any neural network you can run on a massive GPU cluster, you can run to this 1999 game engine.
I want to spend some time on how they actually pulled this off because the implementation is incredible for any engineer listening. They built a bipolar one-bit architecture using the game's terrain and units.
Yeah, this part is fascinating.
Normally in binary, you have ones and zeros, but a standard one-bit setup can't represent negative weights easily without getting into floating point arithmetic, which you obviously can't do natively with medieval villagers.
No, definitely not.
So they used a bipolar mapping where 0 maps to -1 and 1 maps to +1.
That constraint forces some highly creative engineering. They needed a way to physically represent the flow of data. So they created what they call bit rails.
Oh, right.
They used grass terrain to represent 0 or -1, and bridge terrain to represent 1 or +1. And the signal carriers, the actual data moving through the network, are in-game goats.
Goats executing a step function.
Exactly. The goats literally move back and forth along these terrain paths.
That is just amazing.
But, anyone who has ever built a concurrent system knows that timing is everything. If you have 2 inputs arriving at a logic gate, and one goat gets there before the other because of the game's pathfinding quirks, your logic fails.
Oh, so it creates a race condition.
Yes, a literal race condition between goats.
So how did they solve the synchronization problem?
They used patches of ice.
Ice?
Yeah. They placed ice terrain before the logic gates to act as a buffer. The game engine forces units to slide on the ice for a fixed amount of time, which effectively syncs up the signal pulses.
Wow, so that ensures the goats arrive at the computation stage simultaneously?
Correct. And for the computation itself, they mapped XNOR gates to an AND gate to learn logic. But because of how primitive this setup is, they didn't even use a bias adder in the traditional sense.
They just hard-coded the bias directly into the gate structure itself.
It is a masterclass in dealing with substrate constraints. They took the absolute bare minimum requirements of a neural network and forced the collision boxes and pathfinding algorithms of a decades-old RTS game to execute them.
Okay, building a neural network out of digital goats is hilarious and obviously took a massive amount of patience in the scenario editor, but I have to push back here for the skeptical listener. Yeah. How does a 1999 video game actually prove anything about a massive GPU cluster running 100 billion parameter modern LLM? I mean, isn't this just a highly technical parlor trick?
It sounds like a parlor trick. Until you view it through the lens of what philosophers of mind call substrate non-uniqueness.
Substrate non-uniqueness.
Right. This is a crucial concept. Substrate non-uniqueness means that the physical material executing the computation doesn't matter. Only the computation itself matters.
Okay.
If the exact same prompt-to-output mapping of an LLM occurs in silicon, it can theoretically occur in Age of Empires 2.
So you could copy a modern LLM's weights entirely into the game engine, assuming you had an impossibly large map.
Yes. Let's say you do that. You input the text prompt, "I feel lonely." The game engine computes the weights. Millions of goats run across millions of grass and bridge tiles, sliding on ice, triggering collision boxes.
Just a massive, slow computation.
Exactly. It takes hours, maybe days. But eventually, the goats trigger an output mechanism that reads, "I feel bad for you, maybe catch up with a friend."
Right.
Nobody in their right mind would look at those digital goats running around a map and argue that the game engine is experiencing empathy.
Right, because the mechanics are entirely exposed. You can literally watch the data routing. The empathy is completely an illusion of the representation.
The game engine retains the exact prompt-to-output mapping of the LLM. It calculates the exact same math, but it strips away the de-anthropomorphic qualities, the lightning-fast speed, the sleek text interface, the authoritative tone.
It forces you to look at the mechanical reality of the substrate.
Precisely. If you refuse to ascribe human intent to the goats computing the logic, you have zero scientific basis to ascribe it to the silicon computing the exact same logic.
Here's where it gets really interesting, because if the goats don't feel empathy, how do we scientifically measure if a standard silicon LLM does?
Well, the author argues that you literally cannot measure it if you start with the wrong philosophical assumptions.
And this leads us right into the logical trap of the computational theory of mind, or CTM. Let's break down what CTM actually claims.
The computational theory of mind is a philosophical grounding that suggests the human mind is fundamentally an information processing system. It posits that cognition is just computation.
Okay.
Now, the paper isn't taking a stance on whether CTM is true or false for humans. What it argues is that if an AI researcher accepts an interpretive framework like CTM, meaning they assume that human traits can theoretically exist in a machine substrate, and then hypothesizes that a specific trait does exist in their LLM, their experiment is logically doomed from the start.
It's like trying to test if a completely unknown material is magnetic, but your only testing tool is made entirely out of magnets.
That is a great analogy.
You are guaranteeing a specific type of feedback loop and calling it a discovery. If you assume the trait can exist and hypothesize it does exist, a positive experimental outcome is totally circular. You are using the assumption to prove the assumption.
You haven't provided any independent evidence, you've just begged the question. Because you don't have an objective external measuring stick for something as abstract as empathy or anxiety, you are forced to rely on the model's behavioral output.
Right, the text it generates.
Exactly. If the model outputs a convincing paragraph about being anxious, and your framework already assumes the model can be anxious, you log it as a positive result.
But wait, what if the experiment yields a negative result? Say you run a benchmark for empathy, and the LLM just outputs gibberish or acts completely sociopathic. Doesn't that prove the model lacks the trait?
Not under this framework, and that is the core of the logical trap. If you get a negative result, that result is completely uninformative.
Uninformative how?
Well, did the hypothesis fail because the LLM genuinely lacks empathy? Or was the experimental design flawed? Maybe the prompt wasn't tuned correctly. Maybe the temperature setting was wrong.
Oh, I see.
Because you cannot independently verify the existence of the inner trait. You cannot disambiguate a failed hypothesis from a flawed experiment. It's a complete empirical dead end.
And the author points out that researchers try to escape this by just running more tests. They call it the multiple hypotheses fallacy.
Yes.
The thinking goes, well, maybe this one test for anxiety is circular, but what if I test 50 different facets of anxiety? What if I test its response to stress, its lexical choice under pressure, its self-reported state?
It doesn't work. If every single one of those 50 tests relies on the same circular framework where you are just evaluating the persuasiveness of the text, then a union of circular results just creates a bigger circle.
You aren't gathering more proof.
No, you are just gathering more instances of the model successfully mimicking a pattern in its training data.
If we connect this to the bigger picture, this logical trap proves how easily we are fooled by the interface. We are so desperate to find independent verification of these traits that we rely on the persuasiveness of the model's output as the proof itself.
Exactly.
To drive home how absurd that is, the author introduces a thought experiment that makes the digital goats look completely normal. Let's look at the greater Boston area setup.
This is a fantastic modern adaptation of classic philosophical arguments, like the Chinese room or the blockhead thought experiments. The author asks us to imagine a physical system using the inhabitants of Boston.
The actual people.
Yes, there are roughly 667,137 people in Boston. We ask them to act in a unified manner to physically simulate an LLM.
So each person acts as a single logic gate or neuron.
Yes. They text arithmetic inputs and outputs to one another. They literally hash phone numbers to simulate the network's architecture, passing the data along a massive human chain.
And let's say the final output token is represented by a specific action. The final person in the chain physically walks into 77 Massachusetts Avenue, which is MIT's main building.
Right.
The question the author poses is this: if that final token, combined with previous tokens, forms a sentence expressing deep anxiety, does the city of Boston feel anxiety? Are the residents of Brookline serving as the anxiety neurons?
This raises an important question about how technical teams calibrate AI benchmarks today. In the greater Boston area simulation, the computation process is incredibly slow. It is visibly makeshift.
You can literally see the people texting each other.
Exactly. Because of that extreme transparency and latency, no observer would ever ascribe an intrinsic emotional state to the city as a whole.
You just say, wow, those people are really good at following instructions to pass messages.
But when the exact same mathematical process happens inside a massive GPU cluster, and the output is projected onto a sleek chat window with low latency and high coherence, the illusion takes hold.
Yeah, suddenly we call it emergent anxiety or theory of mind.
We are not measuring a change in the system's underlying nature. We are measuring a change in presentation.
The interface is doing all the heavy lifting. We are measuring our own expectations and our own susceptibility to a fast, coherent conversational partner.
Which serves as a devastating critique of how we currently evaluate large models.
Yeah.
Attributes like persuasiveness, self-consistency, or the ability to generate a specific, complex token sequence. Those are objectively measurable capabilities. You can benchmark them mathematically.
But mapping them to an emotion is different.
Exactly. Taking those objective measurements and mapping them to an inner emotional state is fundamentally unscientific. It is an ascription of a trait based on human bias, not an observation of an intrinsic property.
So what does this all mean? If ML engineers cannot trust the interface, and they cannot use traditional accept or reject hypotheses to test for human traits without falling into a circular trap, how should the listener design their AI evaluations tomorrow morning?
We need something actionable.
Right.
The author's proposed solution is what they call the null assumption. It requires a complete methodological reset for the field. Researchers must stop using the accept-reject setup regarding human traits entirely.
So no more asking, does it have empathy?
None. From day one of an evaluation, you do not state, presuppose, or implicitly assume anything about anthropomorphic attributes in the system you are testing.
You have to draw a hard, impenetrable line between the observation of a pattern and the ascription of an attribute.
Let's apply it to a real-world scenario. Say you are testing an LLM's ability to provide a natural language explanation of its own internal state or its previous outputs.
Okay.
Under the old, flawed framework, a researcher might observe the coherent output and label the model's capability as introspection or self-awareness.
Right, which happens all the time in papers today.
But under the null assumption, you are forbidden from using those terms. You treat that output strictly as a behavioral reaction to stimuli. It is token prediction, mapped from an input prompt.
The inputs, the weights, the outputs, they are just mathematical tokens without deeper psychological symbolism.
Exactly. If you are an ML engineer listening right now, building an evil for a new agentic workflow, you need to check the box for causal behavior and explicitly leave the philosophy box empty.
Keep your claims empirically verifiable and strictly constrained to the actual scope of your experiment.
Yes. If your model outputs a sequence of tokens that perfectly matches a psychological profile for empathy, your conclusion must be the model's behavioral output aligns with this specific statistical pattern, not the model has developed empathy.
It might sound overly restrictive to some, but it is actually incredibly liberating for the science of machine learning. It allows us to rigorously test what an AI can objectively do without getting tangled up in metaphysical debates about what the experimenter wishes the AI to be.
Think about it like a thermometer. If you calibrate your thermometer independently against known physical constants, you can reliably measure temperature. But you cannot independently calibrate a test for a machine's soul. So we must stick to measuring the mechanics.
It is a profound shift in perspective. We have to separate the objective reality of the substrate from the illusion of the interface.
You absolutely have to.
Because if our most rigorous evaluations of artificial intelligence are so easily corrupted by a sleek chat box, if simply swapping that chat box for a bunch of digital goats in a 1999 video game completely shatters the illusion of intelligence, what does that say about the metrics we use to track the path to artificial general intelligence? Are we actually measuring generalized intelligence in these massive models, or are we just mathematically measuring our own willingness to be persuaded by a smooth-talking text generator?